All right, so we want to do one, what is this thing? Lagrange problem. Okay.
Yeah.
Out of 15.3, it's number 17. So what are we supposed to do? What did they tell us?
Like maximum and minimum values of a function within the constraint.
Okay, so they want me to max minimize this function f of x in y is x squared y plus 3y squared minus y, subject to the constraint x squared plus y squared is smaller than 10. Okay? How do I do Lagrange?
Partials. Gradient.
Partials. Good.
Grad f equals lambda grad g.
Don't we also have to check within the circle too?
Good. Perfect. So remember, Lagrange multipliers works when this is equality. Right? This equal sign here, they have lesser equals. I'm thinking the equal sign part of that is Lagrange multipliers. What about that not equal sign part of that?
Just the regular set both equal to 0.
Yeah, I got to think about the gradient in there. Good news. To do maximizing, what do I need to do regardless of technique?
Take partials.
Yeah, I got to take the partials. I got to find the gradient of f at least, right?
Yeah.
Okay, so let me find the gradient of both things to set myself up for Lagrange. Okay, so I need the gradient of f and the gradient of g, my constraint function. Okay, gradient of f is
2xy and 6y minus 1.
2xy for the x partial and
Oh, x squared.
6y.
x squared plus 6y minus 1 for the y partial. And the gradient of g, hopefully simpler,
2x and 2y.
is 2x and 2y. Cool. All right, so which piece do you want to take care of first? In the circle or Lagrange multipliers? In the circle? Sure. Okay, so in the circle, I'm looking for where inside, I suppose I should label. I'm looking for gradient of what? Am I doing f or g?
F.
F, the thing I'm trying to maximize, good, equals what?
Lambda. Lambda.
So inside the circle, I'm looking for 0 vector.
Oh.
Outside this, on the edge of the circle, right?
So we're testing the whole function first and then seeing if any of the maxes mins lie in the circle.
If any of the potential maxes or mins lay inside the circle.
So if no such value exists, then we have to do Lagrange?
Yeah, then I'll do Lagrange. I got to do Lagrange anyway,
Yeah.
right? Because I'm still going to have to take care of the edge.
Okay.
So that's where I'm going to do gradient of f is lambda gradient g. But for this one, because they gave me an inequality, I got to do the inside too.
Oh, okay.
So inside, I've got gradient of f is 0. That's 2xy is 0, and x squared plus 6y minus 1 is 0, right? Remember, these have to happen simultaneously. So which one's easier?
X should be 0.
Left?
They can both be 0.
Perfect. Left thing tells you, according to the what?
0 product rule.
Nice. According to the 0 product rule, x is 0 or y is 0, right? Okay. If x is 0, over here, what do you get?
1/6. Oh, no. Yeah, 1/6.
Maybe let me
y is 1.
right this way. Or y is 0. So if x is 0, that forces
Y to be 1/6.
y to be 1/6. If y is 0, that forces
Plus or minus 1.
x is plus or minus 1.
You have to keep those together, right?
Yeah, and these are pairs, right? Yeah, 3 points specifically. So I got 0, 6. I got, what else?
1, 0, and negative
1, 0, and negative 1, 0. These are my potential critical points, right? Well, sorry, these are my critical points. They're potential maxes or mins. Are these all inside the thing they were asking me about?
What's
What's the square root of 5? Oh, square root of 10.
Yes, they all are.
Yeah.
Square root of 10, bigger than 3.
Okay.
These are both 1 unit away from the origin, right? And this is only a 1/6 unit away from the origin. So the radius here of square root of 10 is definitely bigger than this.
Okay.
You guys see that? Okay, so where are these? Inside or outside?
They're inside.
Inside. Crap. That means I have to deal with them. Okay, so let me just record that I have to deal with those. Now, what else do I need to do?
And if they were outside, you just cross them out.
Second.
Yeah, if they were outside, I'd just pitch them.
Second derivative test.
Okay, so for each of these, I could do a second derivative test. I'm not going to.
Don't need to evaluate them.
Yeah, I can just evaluate them at the function because I'm looking for global maxes and mins, right? On this globe here.
Not determining the maximum.
Yeah, I don't need to know whether they're local maxes or mins, right? Because if they're the biggest thing around, that's enough. So in here, let's see, when I plug f of 0 and a 6th, what do I get?
Yeah, 1. So
Or no, okay.
1/12 minus 6.
Okay, it seems like I got 3/36 minus a 6th. And you guys are saying that's something crazy?
It's like negative.
Negative a 12?
Yeah, negative 12.
Okay.
Yeah.
And f of 0 and 1 is, or sorry, 1 and 0 is 0, 0, 0, 0. And f of negative 1 and 0 is also 0. So far, what have I got?
Potentially a min.
I've got potentially the minimum in there, and potentially the maximum is split. Okay, but right now I'm operating on an open set, right? You guys see that? Am I guaranteed that any of these are maxes or mins?
Just that they're critical.
Yeah.
No, because I'm operating on an open set, right? So to guarantee that I have maxes or mins, I need to be operating on a closed bounded set, right?
Yeah.
So what do I do to close and bound this sucker?
Lagrange.
Yeah, I need to run Lagrange on the edge. Right? The edge here being x squared plus y squared is 10. The inside here was x squared plus y squared,
Is less than.
strictly smaller than 10, right? Really, I ran this as x squared plus y squared anywhere, right?
So dot product.
So on the edge, what do I need?
Set the gradients equal to each other.
Set the-
lambda coefficient of 1.
I'm looking for gradient of f is lambda gradient of g. So I've got 2xy is lambda
Lambda 2x.
2x and
And
X squared plus 6y minus 1.
x squared plus 6y minus 1 equals
lambda 2y.
lambda 2y.
And lambda
We can
equals
have
y.
lambda equal to y.
Yeah.
Okay, so here I found out, right, that x is 0 or lambda is y. Okay, if x is 0, what does that mean for this other one? Ew.
Can we simplify it first?
Yeah, very simplified.
Okay. What are you gonna do? Ew. Okay, thoughts? Helpful? Oh my god. Remember, these are underdetermined.
X is 0.
Are these underdetermined? This thing seems underdetermined.
I don't know.
If you don't care about
If you have
lambda.
3 unknowns, then you need 3 equations.
Good. There are 3 equations somewhere. I have 2 of them over there. Where did the third one go?
Oh, the constraint.
Good. The constraint's the third one. So you have 3 equations, right? 3 unknowns. So it feels underdetermined, but you have to remember that there's a constraint. And also you should remember,
Lambda. Doesn't
yeah,
matter.
I couldn't give less of a crap about lambda. Okay, see that? Okay, so what did I find out here? What should I do next?
You divide the
We can find
equation.
lambda in the constraint, right?
No, you could find y squared in the constraint because x is equal to 0.
Ah, good. So far, right, I know that either x is 0 or lambda's y.
Yeah, we don't care
Right.
about lambda, so just put in x equals 0.
So if x is 0, right, then y squared has to be 10. Where did I get y squared is 10?
From the constraint.
It's from the constraint. And what else?
And if y is lambda,
No, hang on. If x is also 0, right? Oh, I guess I don't even need that. Okay, see that? I don't need the other equation because I know what y is.
Yeah.
Right? So if x is 0, y is positive or minus square root of 10.
You can just.
Cool, so there's 2 more points I have to check, right?
Yeah, that's where
And what if lambda's y?
parallel.
Then you have 2y squared equation. Or are we focusing on the other
We can
equation?
solve for lambda on the right one. Yeah. Find that.
So I think if lambda's y, I have to use this equation.
Yeah. So 2y squared, x squared
We can
equals.
solve for lambda, and then we know that lambda's y, so we get x, right?
Can solve for lambda where?
If we say
Oh, on the other guy, I see. So I got, the other guy is telling me that lambda is x squared plus 6y
Minus 1.
minus 1 over
Over
2y. Oh, and I really shouldn't have bothered to divide by 2y.
No, because lambda equals y.
Yeah, lambda's y. So let me just,
Be 2y squared.
2y squared is x squared plus 6y squared minus 1.
Then,
solve for x.
yeah, isolate x
Solve
squared.
for y's that we got, right?
No, that's kind of funky.
That's going to be kind of weird. I want to get rid of the x's, right?
Yeah.
Okay, see that?
Why do we want to get rid of the x? I thought we were trying to find the x.
Oh, good point. Crap. I want to find the x's.
So then, I guess isolate x squared.
Okay. So if I isolate x squared, I got x squared is 2y squared
Minus 6y plus 1.
minus 6y plus 1. Good. Now what? Where do I have another x squared?
Oh.
Yeah, remember you have 3 equations, right? This is the hardest part about Lagrange multipliers, right? Is you get these equations and you have to solve them all, and it's really wacky sometimes. The hardest thing is to remember that you still have a constraint equation. Use the damn thing.
So x squared you can change for 10 minus y squared.
Perfect. So x squared I can turn into a 10 minus y squared. Now I have one equation with just y's in it, right?
Yeah.
And numbers.
3 squared plus 6y minus 9 equals 0.
So my goal was to get rid of the x squared, right?
But you're-
So that I could solve for y.
Yeah.
Then once I know y, I'll be able to go back and find x squared.
Okay.
Okay, so how do you solve this thing?
Set it equal to 0.
Okay, I want to make it equal to 0, so I'm going to need a
It's really nice.
subtract 10, add y squared.
Yeah.
No, it's
So 3y squared minus 6y minus 9.
So I got 3 squared minus 6y
Minus 9.
minus 9 equals 0.
Yeah.
I can factor it.
It's actually nice.
I can divide a 3 through the whole thing. Get y squared minus 2y minus 3 is 0.
Y equals negative
Negative 3
3
plus.
plus
So 3.
Y
equal 1.
minus 3 times y plus 1 is 0.
Yep.
So y is 3 or y is -1.
Okay.
And what does that tell you about x?
You input those into the constraint, right?
Good, put them in the constraint, right? So
X can be 1.
that's x squared plus 9 is 10.
X is plus or minus 1.
So x is plus or minus 1.
And then X is also plus or minus 3.
And x is plus or minus 3. Oh my lord, this thing has a lot of
6
points.
to that.
Okay, so hang on, I'm gonna need to erase some stuff so I'm gonna lose everything. Okay, so on the edge we found points, and they are what?
3 plus. Okay, 1, 3. Okay, 0 root. Plus root 10.
Okay, so let's start with these first ones, right? So we got 0 square root of 10, 0 minus square root of 10. Okay, so that was
The first one.
the ones from x is 0. Then what else did we get?
3. 1. 1, 3.
Okay, we got plus or minus 1 and 3. So we got 1, 3, minus 1, 3.
And
Negative 3.
Negative 3 and positive 3, comma,
Negative 1 on each one.
negative 1 on both. Okay.
This is a gross function.
Yeah, this function's really foldy. You guys see, we know it's really foldy, right? Because it has lots of kind of,
Possible maximum.
yeah.
And so are 0 and 1, 6, and then 1, 0 and -1, 0, do those just
They're still usable, but we're not sure if they're the global maximum.
Okay.
Yeah, so I'm looking for the biggest and smallest number, right, output on this set. It's closed and bounded, so I know it has one. I have 3 interesting things from the inside and a whole mess from the outside edge.
Okay.
What do I do with all these guys?
Plug them into your function.
Plug them into f. Okay, so what do we do? F of 0 and square root of 10. What do we get?
I think we erased that.
Oh, I erased my function. Crap. Okay. Somebody remind me what my function was.
X squared y plus
3y squared minus
X
y.
squared y.
3y squared.
Sorry. X
Plus
squared
3y squared
plus 3y squared
minus 1.
minus 1. Okay, so f of 0 and square root of 10 is 30 minus square root of 10.
Ew.
Okay, f of 0 and minus square root of 10
So
is
30 plus square root of 10.
30 plus square root of 10.
That's probably it.
F of 1 and 3 is
3 plus 27.
3 plus
24.
27 minus 3 is 27. Okay, f of negative 1 and 3 is same thing, 27. F of negative 3 and negative 1 is 9 plus 3 plus 1 is 13.
Wait, what do we think?
Negative 9 plus. It's a negative 1 squared.
It's-
Oh, negative.
No,
Yeah,
why?
the first one's negative.
It's negative 9
Plus 3.
plus 3 plus 1 is what?
Arithmetic.
Negative 5. Arithmetic's still the hardest thing in here. And f of 3 negative 1 is the same, I
Should be
hope.
the same thing,
Okay, so what have I found out?
Plus or
yeah,
minus 3, negative 1 are your
I need
bets.
a new color. Out of,
It's a -5, not a 5.
Still negative.
oh, this one's still negative. Okay.
Plus or-
Arithmetic. That's not even arithmetic, that's transcription.
Point off.
Okay, so I need the biggest and smallest number out of which?
All 9.
Good. These 6 here and those 3 there.
Well, the smallest one is our f of plus or minus 3, negative 1, since they're both the same.
Perfect. These guys are the mins. really, these are the I circled the 5s, the negative 5s. Those are the minimum
Values.
And the
value.
And our only
points
max
are
is the 30
plus
plus
root
square root
10.
10.
Yeah.
Because that's about 33
Yeah.
point something.
And this is definitely bigger than 27, right? So this is the max value. What did they ask for? Did they ask for the max values or the max?
Fine, there's a max.
Okay, so how do you answer this in a sentence?
Yeah, it says find the minimum and maximum values.
Oh, minimum, maximum values. So I'd say
Max values.
the max value
Lie on the point 0.
of f over g equals 10 is, and then,
Is f0 negative root 10.
so I said max value,
Oh,
right?
max
So
value.
30 plus square root of 10 over, and then 0 comma minus root of 10. And similarly,
Yeah.
and the min value of negative 5 is over, what's that point?
Plus or
Plus
minus
minus
3 negative 1.
Plus or minus 3, negative 1. Very good. Done. Extra colon. Doesn't need to be in there. Cool? Cool.
Yep.
Check. Gnarly, right? Super foldy function.
F you Lagrange.
Lagrange multipliers has actually saved us a lot of time and work there,
Yeah, that's true.
right? Because our other option would be, I have no idea, right?